Hello. So now we'll be solving question number 28 from the phase 1, chapter called Forces and the Laws of Motion. Okay. This is exercise 1. Let's see. A cyclist is riding with a speed of 36 km per hour. The speed is 36 km per hour. The first thing we want to do, convert the speed in terms of meter per second. So again, the process is pretty simple. You multiply by 1000, so kilometer becomes the meter, and divide by 60 to 60. So R becomes the second. So 10 times, 6 times, 10 times. 10 meter per second, that's the speed. As he approaches the circular turn, the moment he is approaching the circular turn, this speed becomes the tangential speed. And the radius of the circular turn is given as 140 meters. This is the radius. He applies brakes and reduces his speed at a constant rate of 1 meter per second square. Please understand, the moment somebody talks about the circular motion, the net acceleration is AC plus AT. This is how we represent the acceleration. Where this AC is responsible for change in direction. So direction will be changing. So this AC can never be zero. And the AT is responsible for changing the speed. And here they are saying it. The moment he applies the brake and reduces his speed, at a constant rate. So this is the rate of changing the speed, the AT. So in the question itself, with the language, they have given the value of AT, and that is 1 meter per second square. That's the AT. They have directly given it, but they have used the language. In this particular case, when you calculate the AC is V square by R. That's the formula for AC. We have, and R also we have. So we'll just put the values. So 100 by 140. 5 and 7. So 5 by 7 meter per second square. So we have the AC and we have the AT. So what is the magnitude and direction of net acceleration of the cyclist on the circular turn? Let's take the circle. Let's say this is the circle and this is the turn we are talking about. Direction of AC will be always towards the center. And let's assume the movement is clockwise. So tangential acceleration will be in the backward direction because you are applying the brake. And to calculate the direction, this is the direction of A net. By default, you should be giving the direction with respect to the normal default. So this is the angle theta I'm defining. So theta I'm defining with respect to the normal radius. This is easy. So let's first calculate the direction in terms of theta. The tan theta will be equals to, in this triangle, if you see, the tan theta will be equals to perpendicular, which is 80, divided by base, which is AC. So 5 by 7. So tan theta comes out to be 7 by 5 and theta comes out to be tan inverse 7 by 5. So that's the angle. The net acceleration will be making this angle with the radius. And the magnitude of the acceleration will be equals to under root of AC square plus AT square. We'll write the values of AT as well as AC and we get the value as 1.22 meter per second square. So the cyclist basically will be having the net acceleration equals to 1.22 meter per second square. And the direction of this net acceleration will be tan inverse 7 by 5 from the center, or radius basically. Okay. Thank you.